So previously we talked about voltage, current, and resistance. And today we're going to keep talking about those things. We want to look at how those three things are related. Ohm's law shows the relationship between these three things: voltage, current, and resistance. It can be represented by this formula: voltage, which is represented by V, or measured in volts, which is represented by V. Current, which is measured in amps, which can be represented, you can write out amps or just an A, times resistance, which is measured in a unit called ohms. Now, be sure, and as we work through these problems, make sure that you understand the units that each of these things use. Okay, so you might need to refer back to this. This is another way V equals IR that the formula is written: voltage equals current times resistance. Now, it might be a little bit confusing because in our formula, voltage is represented by V and resistance is represented by an R, but current is represented by an I, which is a little bit weird. You would think it would be C, but it's I. In your notes, you have this formula rearranged to figure resistance and current, and so you might want to refer back to that as we work through these problems. Okay, our first example problem says a light bulb is plugged into a wall outlet. If the light bulb has a resistance of 220 ohms and the current in the light bulb is 0.5 amps, what is the voltage provided by the outlet? Now, the first thing we always want to do is start by just listing out what you know, the information that is given to you in the word problem. So here we know that current, which is represented by the I in our formula, is 0.5 amps. And we know that resistance, which is represented by an R in our formula, is 220 ohms. Okay, this means that we need to find the voltage. Okay, so I just went ahead on the next slide and put what we already know at the top so it can help us remember here. So what we want to do next is to go ahead and substitute the known values for the current and resistance into our Ohm's law equation, which was V equals IR, in order to calculate the voltage. Okay, so we've substituted our 0.5 amps for I times our 220 ohms, which was R, and that gives us 110 volts. Again, we have to remember to put the units on there. Okay, let's look at our second problem. An electric iron plugged into a wall socket has a resistance of 24 ohms. If the current in the iron is 5 amps, what is the voltage provided by the wall socket? Okay, or provided by the outlet. Okay, so the first thing, again, that we want to do is go ahead and write down the information that's given. The first piece of information that's given is our resistance. So our R equals 24 ohms. Okay, the next piece of information that is given is the current. So that's I equals 5 amps. That means that we are looking for the voltage. The next thing that we want to do is plug our given numbers into our equation. So for I, we have 5 amps times our resistance, which is 24 ohms. 5 times 24 is going to give you 120 volts. Okay, let's look at our third problem here. It says, what is the current in a flashlight bulb with a resistance of 30 ohms if the voltage provided by the flashlight batteries is 3 volts? Okay, again, we want to write down the information that's given. The first piece of information given is our resistance. Okay, R equals 30 ohms. The next piece of information is our voltage. So this is 3 volts. That means in this case, we are looking for our current. So we can take our original equation, V equals IR, and we can plug in the values that we know. So our voltage is 3 equals I, we don't have I, times our resistance, which is 30 ohms. Now, in this case, you're going to have to go ahead and solve for I, which is just like solving for X. In order to get I on one side by itself, you would simply divide both sides by 30. Okay, this side's going to cancel out, leaving I by itself. When you do 3 divided by 30, you get 0.1 amps. That's going to be your current. Now, there's another way to do this if you don't want to solve for the I. You can go back and look at the beginning of your notes and find which equation has I on one side by itself. Okay, it's going to give you I equals your voltage divided by your resistance. Then you can simply plug in your known values. So we'll have our voltage, which is 3. Cross that out. And we want to do divided by our resistance, which is 30. So you can see it would end up being the same thing that we came up with over here. So it would give us still our current of 0.1 amps. Okay, the last example that we have, we're going to go through right now, says, what is the resistance of a light bulb connected to a 110 volt wall outlet if the current in the light bulb is 1 amp? We always want to start by writing out the information that's given. Okay, so we have our voltage, 110 volts. Okay, the current is 1 amp. That means we're looking for resistance. Again, there's 2 ways that you can do this. You can simply plug these numbers into our original equation, which is V equals IR, and then you can solve for the R. So that gives us 110 equals 1 times R. Okay, if you divide both sides by 1, those will cancel out, leaving R by itself. 110 divided by 1 is still 110. Remember, we're looking for resistance, so our unit here is going to be ohms. Or if you want to go back and find the equation that has R, the resistance, on one side of the equal sign by itself, you could also do your resistance equals your voltage divided by your current. So in this case, we would just still plug in our values. 110 divided by 1, and that's still going to give us 110 ohms.